I am going to start recording now. Okay. Let me go ahead and talk a little bit about turning in homework before we get into homework questions, because there's two things I need you guys to change, because only maybe like a handful of people did this, and I need everybody to do this. Okay, so everybody pay close attention so that you don't get docked off points next time. So I didn't dock off points this time, but I will next time. Okay, so two things I need you guys to do. So hopefully you guys know where to turn in your homework assignments. So if you go to Schoology, you're going to go to the folder chapter 1, homework, and this is where you turn in your assignments. Okay, so the first one, hopefully you guys click that and then submitted. One thing you guys need to do is I need you guys to actually convert your pictures to PDF. Okay, a lot of you guys turned in images, which I told you to do. Okay, so totally fine, but I realized that as I was grading, it took forever to load these pictures. So if you guys turn into PDF, it's a lot faster for me to go through your homework assignments. So if you don't know how to do that, two things: you can find an app on your phone that does. I'm pretty sure you can find plenty of apps that will turn pictures into PDFs. Or if you don't want to download an app, under updates, all right, I posted the instructions on how to submit your first homework assignment. I've included a link on how to convert your photos to PDF on your iPhone. If you have an Android, I have a different link. You can email me for that. So if you don't want to download an app, this is how you can do it without downloading an app. But if you want to just download an app because it's faster, feel free to do that. But I need you guys to upload these homework assignments as PDFs, okay? All right, so that's the first thing. The second thing I need you guys to do, and this was on the syllabus, is to correct your homework with a different color pen. Some of you did it, some of you didn't. I kind of forgave you this time if you didn't, but starting from this homework assignment tonight, lesson 2, I will dock off points if you do not correct your homework with a different color pen. So what I mean by that, and what I'm looking for, is if you got a question right, put a check mark with the different color pen. Show me that you checked it, it is correct. If it is incorrect, then go ahead and make corrections with the different color pen. All right? All right, so those are two things I need you guys to do for homework. Any questions about that? Okay, awesome. All right, let's go into some homework questions. So in the chat box, I'm only going to be able to do 3 max because of time. So in the chat box, go ahead and type in any questions from the homework that you want to see, and I'll take the top 3 most popular questions. If you want, you can private message me, or you can message it to the entire class. It's totally up to you, but either way I can see it. So go ahead and type in your questions. A few more seconds. All right, is 27 a book problem or a worksheet problem?
Worksheet.
Oh, it's worksheet? Okay. Thank you. Okay, ooh, lots of 27s. Okay, I think 27 is the only one that I see repeated. 59 is another one that I see repeated. Okay, so 27, 59 from the textbook, thank you. 27 and 59, okay. And is that Jamie?
Yeah, just keep constantly joining the wrong Zoom.
Okay. All right. I'm not going to mark you tardy this time, but next time I will, okay? All right. Let's see, 27, 59, and those are the only repeat ones. Okay, so I'll go ahead and do that. So to make this actually go faster, what's going to be easier is if I can actually pull up somebody's homework to show the work, and that's a lot faster than me just writing it on my iPad. So Do I have any brave volunteers for 27? Did anybody get 27 on their homework and will allow me to show their homework to everybody so everybody can see how it's supposed to be done?
I got 27.
Awesome. Thank you, Faith. Okay, so I'm going to pull up your homework. Oops, wrong period. And 27 from the worksheet. You guys can still see my screen, right? Okay, awesome. All right, Faith, let's see. All right, and you guys can see what I mean by it takes forever to load a picture. Yeah, so imagine doing this for all students for like 3 pages. It's like 300 of these loads in one day. Okay, so worksheet 27. Okay, there you go. All right, so this was one of those evaluating problems. So Faith, it looks like you plugged in A, which is 3 over 4, C, which is -2, D, which is 3, C is -2, and G was, is that 1 over 9, Faith?
It's 1 over 3.
It's 1 over 3.
Oh, okay, got it. Sorry. Yep, 1 over 3. Let me zoom in. There you go. That's easier. All right, so then she took care of the grouping symbols by doing the numerator exponent first. So -2 to the 4th gets you 16. All right, and then 3/4 times 16 gets you 12. And then 12 over 3 gets you 4. Nice. All right, and then 1/3 square gets you 1 over 9. And then -2 is on the top. So right here, remember, -2 divided by 1/9, you multiply by the reciprocal. So -2 times 9 gets you -18. But because you're subtracting a negative, that's how she got plus here. All right, or actually really smart, what she did was she multiplied top and bottom by 9, and that gets rid of the denominator. So that's another way to do it. Good job. All right, so -2 times 9 gets you -18. Minus a negative gets you positive. So 4 plus 18 gets you 22. Good job. Nice. All right. Let's see. Any questions on that one still? Okay. All right. Let's do number 59, I think was the other repeat. 59 was textbook. Faith, since I'm on yours, do you mind if I show 59 also?
Yeah, but I didn't get that one right. Yes.
Oh, shoot. Okay, no problem. Did anybody else get it correct that you're okay with showing work?
Yeah, I think I got it correct.
Awesome. All right, thanks, Ryan. Let me see, where's Ryan?
Some steps though, I just like write down the steps, and then some of them I do it in my head though, so I don't know how it's gonna look.
Okay, well you might just need to kind of tell everybody if there's some steps missing, okay?
Sure.
Awesome. All right, so 59, there it is. All right, so this one had a bit of, let me see, let me read the problem so you guys know what that problem was. All right, so 59 says, an integer is 2 less than a number. All right, so 2 less than a number, so x minus 2. And another integer is 1 greater than double the same number. So double the same number x plus 1 greater. And then the sum of these two is equal to 14. So I think he added those two together. So x plus 2x gets you 3x. Negative 2 plus 1 gets you minus 1 is equal to 14. And solving for x, you get 5. Now plugging 5 back into this, you get 5 minus 2, which is 3. And then 5 times 2 plus 1 gets you 11. And that's your final answer. All right, good job, Ryan.
Thank you.
Okay. All right, any other burning questions? There's one slot left. First person to type it into the chat, I'll do that one. Go, even if you typed it in already. 35. Ooh, good job, Yuki. All right, so 35. Yuki, is that textbook?
Yeah.
Yeah, okay. This was the geometry one. Ryan, did you get this one?
Yeah, I got all of them right, I think.
Oh, well, look at you flexing. All right, number 35. This was the one that had like this triangle pyramid with the circle base. All right, it says the formula for the volume V of a cone with radius r and height h is this formula up here, right there. He wrote down. Write an expression for the volume of the cone at the right. All right, so they gave you the height of the cone is 2x and the diameter of the base is 6x. If the diameter is 6x, that means the radius is 3x. So that's why r is 3x and h is 2x. All right, and using PEMDAS, we're gonna do exponent first. So 3x squared gets you 9x squared. And the rest is just multiplication, so multiply it all together. So 1/3 times 9, which is 3, times 2, which is 6. And then x squared times x gets you x cubed, and what's left is the pi. So final answer, 6x cubed pi, or I think the book has 6 pi x cubed. Doesn't matter which order. All right, good job, guys. So that is it for homework questions. If you guys do have other questions, feel free, email me for office hours, and then I can walk you through some other problems, okay? Especially before our quiz on Friday. All right, okay. All right, well, I'm gonna get started. So here we go. Properties of real numbers. So we have 2 parts of the lesson today. We're gonna talk about these number sets, and then we're gonna talk about properties as well. Okay. Oh, got it. Okay, thanks, Gina. All right, so let's talk about these number sets first. All right, so go ahead and draw a bigger box around the entire thing. And this box represents all real numbers. Okay, so real numbers are gonna be like every sort of number you guys can think of. Okay, so anything that you've come across in your life so far is a real number. Decimals, fractions, all of it, okay? So those are real numbers. And then we have next is our rational numbers. And so our rational numbers, right here, are all numbers that can be represented in this fraction form, m over n, where m and n are integers. Okay, they have to be integers, and to be able to write it in that fraction form, that's what makes a rational number. So for example, 1/2 is a rational number. Negative 10 over 3 is a rational number. 12.5 is a rational number because I can write that as a fraction. 0 is a rational number because 0 you can write it as 0 over 1, and you can write it in fraction form. So anything you can write in fraction form where m and n are integers, that would be a rational number. All right, and everything else is considered an irrational number. Okay, so anything that you cannot write as a fraction, any non-terminating, so that doesn't end, non-repeating decimal. So a decimal that goes on forever and has no repeats, that would be irrational. All right, so for example, pi is the most famous one, right? 3.14159, dot, 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 dot. It keeps on going forever and doesn't repeat. Another one would be like rad2. If you put that into your calculator, it's a decimal that keeps on going without repeating. Rad3 for that matter. Not rad4 though, because rad4 is equal to 2, which is a rational number. But rad 5, yeah. So any radical you can't like simplify to a nice number would be considered an irrational number. Okay, integers. So integers are these numbers right here, like -3, -2, -1, 0, +1, +2, +3. I like to think of it as any number you would tick on a number line. Right, so any number you would like draw one of those tick marks for on a number line, that's an integer. Okay, and then next we got whole numbers. And whole numbers are the positive integers plus 0. Okay, the positive integers plus 0. And an easy way to remember that is it's a whole number with a whole. Okay, so whole like H-O-L-E, whole numbers have the whole 0. Whereas your natural numbers do not. So your natural numbers are just the numbers you naturally count with. All right, natural numbers are the numbers you naturally count. So 1, 2, 3, 4. All right, I'm already teaching my baby numbers, so I'm like using his fingers, like 1, 2, 3, 4, 5. All right, so these are your natural numbers. Okay, any questions about those sets before we get into some problems?
Wait, I don't really get whole numbers like in between natural numbers because that confused me.
Yeah, no, totally. Whole numbers and natural numbers, they have a huge, huge overlap. They are pretty much the same with one exception. Whole numbers include 0. Natural numbers do not. That's the only difference. Good clarifying question. Nice.
And with real numbers, when you say that, or not real numbers, with rational numbers, does that include all like whole numbers too? Because it could technically be like something over 1.
Definitely. Yep. So like 5 would be considered a rational number because you can write 5 as 5 over 1. Nice. Perfect. Good job. Okay. Other questions? All right. Let's get into it then. Here we go. So number 1, we have 6 over 7, and we want to write the sets of numbers to which each number belongs. All right, so first thing, what I do is I work from the biggest set down. All right, so first off, it's a real number, okay? So I'm gonna start with R. And by the way, all the shortcuts are right here. So if you don't wanna write the entire real number, rational number, all of it, you can use these letters and it's a lot faster. Okay, so we got real number. Then the second question you want to ask is it rational or irrational? Rational or irrational? In this case, it's written as a fraction already, so definitely going to be rational. So I'm going to write a Q for that one. All right, so if it's rational, it's not irrational. So I'm going to skip the I. Integer, that is not an integer. I would not mark that in a tick, or I would not see it on a number line as one of the tick marks. So once you hit a no, that is your final answer. It won't be any of the others. Okay, any questions there? All right, let me do another one. Number 2. So number 2, I got negative rad 81. So I'm going to go ahead and rewrite that as -9. And I'm going to go for the biggest set inward. So starting with real numbers, it definitely is a real number. Then I'm going to think rational or irrational. I can write that as a fraction, as -9 over 1. So this is definitely going to be rational. So I'm going to write a Q. Then I'm going to think, is it an integer? Yeah, I can see this on a tick mark on a number line. So I'm going to say that's an integer with a Z. I don't know why it's Z, but it is. All right. Then I'm going to think, is it a whole number? Whole numbers are positive integers and 0. This is a negative integer, so that means it is not a whole number. So I'm going to stop. And that is my final answer. Okay, any questions? Okay, let's do this. There's a few more here. I want you guys to choose what you think is the hardest one, and I'll go and show you that one. Which one do you think is the hardest one? Or the trickiest one, if any?
7.
7, yes, good. Yeah, 7's a little tricky, so let's walk through 7 together. Okay, so what do you guys think? Is this a, okay, go ahead and do the participants thing. Okay, so yes or no's, yes or no's. So first one, is it a real number? That should be a quick one. Yes or no? Is that a real number? Alyssa, Arwen, James, Jamie, Ryan.
Can you hear me?
Oh, yes. What's up, Arwen?
Yeah, I said that I had no questions, but like I was saying stuff earlier and no one responded, so I was like confused.
Oh, okay. I'm just asking yes or no. Yeah, so green, yes, if it's a real number. Okay, thank you, thank you. Arwen, you got it? Still waiting for Arwen's green.
No, what? Did I not? No.
There it is. Okay, yes, it's a real number. Good job. All right, second, is it rational? Yes or no? Is it a rational number? Ooh, I'm seeing some yeses, some nos. Is it a rational number? I see some yeses, some nos. Ooh, okay, this is where it gets tricky. All right, so the answer is no. This is not a rational number. This is irrational. The reason why is you can't just look at the fraction, right? Up here it says it's in fraction form where m and n are integers. So if you look at number 7, that numerator is not an integer. Rad 5 is not an integer. So that is an irrational number, okay? Once it's irrational, that is it. You are done. It's not going to be any of the other ones. Okay, so go ahead. I'm going to have you guys practice with the rest. So I'm going to put you guys into breakout rooms. Try, let's do we'll do number 3.
I have a question.
Oh, question, yes.
Can any like whole number be an integer?
Yes, so if you look at the picture, the entire integer is, the entire set of whole numbers is integers. So if it is a whole number, it is an integer. Okay, all right, so let's have you guys do number 3, number 4, and 8. 3, 4, and 8. All right, I'm gonna put you guys into breakout rooms and we're gonna do 3, 4, and 8 together. Once you are done, leave the breakout room and come back to the main room so I know that you are ready. All right, here we go to your breakout rooms.
I got kicked off the meeting for some reason when I tried to join the breakout room.
Oh no. Okay, no worries. Do you know what breakout room number it was?
4, I think.
4? Okay. All right. You're like on twice, which is interesting.
Oh, really?
Yeah.
Hmm.
It's okay. Don't worry about it. Let me
Alright.
put you in breakout room. Actually, I'm gonna put you in breakout room 9 because that's short of.
Okay.
Alyssa, are you in a breakout room?
No, I got kicked out when I tried joining another breakout room.
All right, let me go and put you in one. Here you go. All right, we're just gonna wait for other people to start finishing up. Just go and relax, guys, while we wait for everybody else. Maddie, did you get kicked out?
I accidentally hit leave meeting instead of leave break room.
Okay. No worries. Happens all the time. All right, I think everybody is back. So let's go ahead. I'm gonna ask you guys for your answers. So tell me what you and your group got. All right, we're gonna start with Alyssa. All right, so number 3, Alyssa, what did you guys come up with? Alyssa, are you there? Uh-oh. Okay, we lost Alyssa. Let's go to Heidi.
For number 3.
Yeah, for number 3.
Okay. I got a rational number, or a real number, a rational number, an integer, and a whole number.
All right, perfect. Good job. All right, so it's all of those except It's not natural. Good. Awesome. All right, let's go to number 4, calling on Mason.
I got real, rational, integer, whole, and natural.
Good. All right, so real, rational, integer, whole, and natural. Good. Running out of room. There you go. Perfect. All right, so that one had everything except for irrational, of course. So that was everything. Good. All right, let's go to number 8. This one was the toughest one. Yuki, were you guys able to figure this one out? What did you get?
We got real number and rational.
Good. Nicely done. And that is it. So you can write this as a fraction. This is 33 1/3, which you can rewrite as 100/3. So that definitely is rational, but it is not an integer, and so it's not everything else. Good job, guys. All right, any questions on these number sets? Okay, let's go on to our properties. So quick question for you guys. Looking through these properties, we got commutative, associative, identity, inverse. Don't worry about closure. Let's cross that out. And distributive. Okay, so yes or no, have you guys seen these before? Yes or no, have you guys seen these before? Yes or no, have you seen these properties before?
Yes.
I'm looking at the participants button. So green, yes, red, no button. Okay. Jamie, are you doing that on purpose? Jamie's is like flashing. Okay. All right, so most people have, which is great. Now, what I want you guys to do is be able to identify when these properties are being used. So since you guys have mostly gone through it, I'll go pretty quickly, but if you are not sure about something, please ask, okay? All right, so commutative is you look at the order changes, right? A plus B becomes B plus A. So when the order switches like that, that's commutative. Associative, notice the order does not change. You got A, B, C, and on the right-hand side, you still have A, B, C. Order stays the same. The only difference is the parenthesis has moved. So when that happens, that's associative. All right, identity. Identity is if you add 0 and you get the same number, or if you multiply 1 and you get the same number. That's identity property. Okay, inverse is if you add the opposite of each other and you get 0, or you multiply a number times its reciprocal and you get 1. That's inverse. All right, and distributive is when you multiply into a parentheses. All right, and that's distributive. Okay, so quick refresher on those properties. What your goal is to be able to identify when those properties are being used. All right, so let's go ahead and practice that. Okay, so number 9, name that property illustrated by each equation. So what you guys want to focus on and highlight is what looks different. What looks different. So going from the left-hand side to the right-hand side, I notice this is now this. All right, so that is what's different. And what happened was they switched the order from 4y plus 3x and they switched it to 3x plus 4y. So because that order switched, this is going to be commutative. All right, and that's number 9. Number 10, doing the same thing, I'm going to look at what looks different. So here I have 7x plus 9x plus 8. Right-hand side, 7x plus 9x plus 8. Order is the same. The only difference is these parentheses have moved. So that is going to be associative. All right. Oh, yikes, this handwriting. There we go. Okay, associative. All right, next, number 11. We have look for what is different. I have a y here, and it became a 1 times y. All right, so that is identity. Okay, and that's how it's done. Any questions on identifying your properties? Okay, if not, I'm gonna have you guys actually finish off problems numbers 12 through 17. All right, 12 through 17, I'm gonna put you guys back in the same groups. Once you're done, come back to the main room and then I'll see what you guys got. Okay, go back into your breakout rooms. And Maddie, I'll put you in, do you remember what room you were in?
I was in the first room, room 1.
Okay, there you go.
Thank you.
You're welcome. Ryan, where are you? Ryan. Ryan, there you go. All right, I'm going to call everybody back. So start getting ready to share your answers, guys. Okay, I think everybody is back. Let's go ahead and go over the answers and see what you guys got. Okay, listen for your name. Here we go. First person, Yuki. What did you guys get for number 12?
Associative.
Good, nice. Associative. Sophia, what did you guys get for number 13?
Distributive.
Ooh, no, not distributive on this one. This one, there's no parentheses that you're multiplying into. This one, the order of how you multiply it is switched. So if you're changing the order that you multiply, anybody, what property would that be? Changing the order.
Associative.
Commutative. Remember, associative, the order doesn't change. Only the parentheses moves for associative. Commutative, the order switches. So number 13 is commutative because the order that you multiply changes. Okay? You can think of this. I think the way they wrote it is tricky. So you want to think of this as this is 3 times x times 2 times y. And they switch the order to 3 times 2 times x times y. All right, so they change the order. So that's commutative. Okay, nice. Let's go to 14. Jamie, what did you get for number 14? What did your group get? Jamie?
Identity.
Good, nice. Oh, wait. Do you say inverse or identity?
Identity.
It's actually the other one. All right, so this is actually inverse. So what changed was you went from 6 plus -6, so 6 plus the opposite gets you 0 and ended up with 0. So that actually is inverse. Inverse. Identity would have been like if it said 6 plus 0 y is equal to 6y. That would have been identity. Does that make sense? Do you see the difference? Okay. All right. Let's go to number 15. 15, tell me what you guys got. Let's see. Geo, what did you guys get for number 15?
I got commutative, but I don't think that's right.
You are correct that it is not right. Okay, so let me help you out here. So here, let's look at what's different. Focus on what's different. It went from 1/4 times 4 to 1. Okay, 1/4 times 4 became 1. So look through your properties. Which one looks like that? Geo, I'm still just gonna stay on you. What property do you think, Gio, does that look like?
Inverse.
That is correct. Yes, good job. All right, so that is inverse. So yeah, highlight the problem if that helps on what looks different, okay? All right, because of time, I know the period has ended. Let me go and give you the answer for the last two. 16 is distributive, 17 is identity. 16 is distributive, 17 is identity. All right, so homework, remember, make sure you check your answer with a different color pen, show a check mark if it is correct. If it's not, make corrections with a different color pen, and don't forget to change it to a PDF. Okay, if you guys have any questions, feel free to email me. All right.
Is the homework just in the book?
Yes, just the book, no worksheet this time.
All right.